This is the kit that came with the Polymer Capacitor Design Challenge. There's a nice little case with 18 compartments in it, and each little bag in each compartment has some capacitors, different types. I actually got two the same because I asked for them for the specific test that I want to do, and they came in these little bags. These are the little capacitors that I got there. I removed one because I wanted to measure it. Also, we got a box that has an interesting meter in it, an Atlas ESR meter. And a manual. So here's the meter, plugged in there very good. Comes with a nice set of alligator clips. The Peak Electronic Limited Atlas ESR. Automatic discharge function. Monitoring for component. Oh, let's find a component. Got a big one here, just this does not have polarity on the leads that I can see. So we'll just connect it up and see what happens. Capacitance 492.6 microfarads. ESR is 0.46 ohms. And this is a 470 microfarad capacitor, 16 volts. So it's says 492, which is pretty close. So the capacitance that I want to measure, I've put in this vise here. And let's see if I can actually get these leads on it. .46 microfarads. ESR is 0.07 ohms. Cool. So one of the things I want to do is compare different meters. So for example, I have here a Vichy meter. Okay, so this one does measure capacitance. Let's put it on the capacitance scale and see if we can get the leads on the right place. Okay, so it says 10.14 microfarads. And one thing I'm going to do is see what waveform these things are using to measure the capacitance by looking at it with a scope. Oh, we have a visitor. But let's look at a different meter. So here we have the big key sight. Which can also, of course, measure capacitance. Let's see if we can change the range to the 10 microfarad scale and stick it on here. 9.898 microfarads. Again, I'll want to look at that with the scope to see if there's some difference. So that's 2 meters. Here's a third meter. A common capacitance. Yeah, I collect meters like some people collect stamps. There we go, 10.07 microfarads. And naturally this is a 10 microfarad capacitor. That's a polymer cap in there. And what I'm going to be comparing it to is this little thing here, which is a 10 microfarad multi-layer ceramic capacitor. Let's just see if we can measure the capacitance on that. This auto ranging thing takes a while. .6 microfarads. So I'll be measuring the voltage that these things generate and the frequency and so on. See what just exactly how they're measuring these. Okay, I've got the little capacitor here that I was measuring before. Put this on capacitance. I have a scope probe hooked up to the tweezers here. And I can grab this capacitor and look at the waveform. So this meter is measuring 9.43 with the scope probe hooked up. A bit of a weird waveform, but it's obviously charging and discharging this capacitor. So let's try that with a different meter. What's this thing measuring at? Plus and minus 1.28 volts. We're on 200 milliseconds per division, so it's about 4 divisions per cycle. So it's almost a second, 800 milliseconds, I think. So let's try a different meter. So this is plus and minus 3.22 volts. And again, one cycle is about, well, from peak to peak is about 400 milliseconds. And it's 9.362 microfarads. One more meter to try. This one's like the first one, 1.23 volts, plus and minus. And the period is also this similar, about 800 milliseconds. And this capacitance is 9.53. So I would like to try this with the other capacitor. So this is the polymer capacitor, and I have no idea if I can really grab it properly. Oh, you had it there for a sec. So 1.12 volts, and the period was similar. These are not made to be picked up with tweezers. But the period is about 800 milliseconds, 1.17 volts, and the capacitance was 10 point, let me get that back in on the leads. .31 microfarads. Pretty tricky to do that measurement. Back through the meters. This meter, the key site. Try and grab it again. Okay, plus or minus 3.12 volts. Period is about 400 milliseconds, and the capacitance is 10.007. So the key site uses a little higher voltage and a little higher frequency. And the Mastercraft. .56 microfarads. .31 volts, plus and minus 1.3, and the period is still around 800 milliseconds. One meter that I didn't check, of course, is the peak. Now I'm going to have to connect the probe up to that one. Okay, we have the peak Atlas ESR meter here, and we're going to measure the same capacitors as before without the scope probe. So the multilayer ceramic capacitor is measuring at 8.72 microfarads and 0.36 ohms ESR. The polymer cap is measuring at 9.44 microfarads. Whoa, we don't have good contact. 9.53 microfarads with 0.38 ohms ESR. And I want to try that with the reverse polarity just to see what happens. .52 microfarads and 0.48 ohms. I think there's some contact resistance there. It seems to be pretty similar in both polarities, and this thing doesn't seem to use polarity. But I'm going to try hooking it up to a scope probe and to find out why. Okay, so for the multi-layer ceramic cap on this thing, we can see why. So we have about 70 millivolts only peak to peak, and the period is about 120-130 milliseconds. So it's a much lower voltage and a significantly higher frequency than the other meters. But with only 70 millivolts, I guess they don't think it matters if the thing is the wrong polarity. So here we're going to put on the polymer cap. And the waveform is pretty much the same, 65 millivolts and 130 milliseconds. The capacitance is 9.53 with an ESR of 0.45 ohms. I'm just going to try that in reverse. So the waveform is the same, and so is the capacitance and the ESR. So with that low voltage, it seems to not make any difference which polarity you use. And that's an interesting meter. It uses quite a different waveform to measure the capacitance and ESR.